Welcome back. My name is Jesse Helms, and today we're going to talk about the second part in our reverse engineering process of the TurboAir part, and this will be the mesh data optimization and UCS alignment. In the previous part, we took the scan data and we created a high definition mesh. Now this high definition mesh has some properties, and here we can look and we can see that it has about 1.8 million polyphase counts or triangles. So one of the things that we can do when processing this data to get it ready for CAD data is we can do things like global remesh and also optimize remesh. So the first thing we're going to do is we're going to do the global remesh, and what the global remesh is basically going to do is it's going to take the triangulation and it's going to help equalize it in certain areas and just clean up the triangulation overall, making it a cleaner mesh to work with. Now this isn't necessarily needed right after doing your own scan data, but where it really helps is when you're bringing in other scan data or STL files from other places. Again, this is all done in Geomagic Design X, and with this global remesh it just makes it a cleaner mesh to work with and for downstream applications. So, and as you can see, there's not really much of a change when I did that process. So the next thing we're going to do is optimize mesh. Now the optimized mesh is very important for downstream CAD applications where we want to turn this into an actual physical model or even do things called auto surfacing. We have a lot of different settings and options in Optimize Mesh that we can do. We're going to go ahead and leave it default for now for this one. We'll go ahead and start it. Now, depending on the size of the file, how much data is there, the triangulation count, it can take a while to do these processes. Anywhere from a minute to many minutes. It just depends on how much data, what kind of resolution you scanned at. So in this case, it didn't take too long. We'll go ahead and process that. And you can see there's really visually not much of a change here. What it's just done is it's allowed the system to optimize this mesh, which is going to make it easier to work with. And you can see here the polyphase count is actually dramatically reduced. And we did that without reducing the actual accuracy. And in those tools we can actually do deviation controls. So we'll go ahead and do the next step here, and this is auto segment. And with auto segment, what it's going to do is it's actually going to create region groups. It's going to pull regions in this part that are things like planes or cylinders or revolves. It's going to find these areas and section it up so that we can extract data from that. We can also use this data to create reference geometry so we can align this to an actual UCS. One of the big things with working with any CAD data, we like to have it aligned or have some kind of orientation to an actual UCS. In this case, what we're going to do is we're going to actually create some reference data. So here I'm actually creating a mirror plane or a center bisecting plane that's going to go right through the middle of this part. And the goal here is to basically, create enough reference data where we can align this part centered up on a UCS, because when we scan this data there is no reference to a global UCS per se, or a universal coordinate system. And ultimately, before we create the CAD data, we want to make sure that it is located in reference to some kind of UCS. So when it does get exported out and imported into things like SolidWorks or Inventor or whatever, Pro-E, that the end user has an actual location of front, top, right, or XYZ planes to work with. So again, we're creating reference geometry here between planes. We're creating some axes, some points, and we're going to use this reference geometry to again locate it against the front, top, right, or the UCS plane. So I'm going to come in here in the interactive alignment. And now with the reference geometry that I've created, I'm going to go ahead and start selecting that reference geometry to orientate it. So you'll see on the left side where I have my selection, and on the right side it's giving me a preview of how this part is being orientated. And I have the ability to change the direction of some of the location for XY as far as a negative, positive direction to the UCS. And you can see that it's all set up now. So now I've done that, I'm going to turn these planes off, turn these vectors off, and you can see that this part is now aligned to the actual UCS. So the next step after this will be to actually start modeling. Thank you for your time, and we will see you in the next step.